I'm delighted to introduce in a moment Peter Maynard. Peter is our Senior Vice President for Data Analytics. He works in the States, and he's one of those wonderfully rare people with a PhD that can make the most complex things understandable. So please welcome Peter.
So I want to thank Kenneth. I'm an economist, and I just love any slide that shows Adam Smith in it. I just think that's brilliant. So anyways, it's really interesting. I mean, just the times that we're in and kind of the economic regimes that we're under and how it impacts our businesses, right? And so what I'm going to talk about is how Equifax has embraced explainable AI, what we've been able to do using these state-of-the-art algorithms to actually improve the ability to make better business decisions. And let me just kind of build on what we're about, right? And so we take best-in-class data, we take advanced analytics, we combine it with state-of-the-art technology, all for the sake of the consumer, right? It's what Matthew talked about earlier, right? How can we enable them, the consumers, to have better livelihoods with this, right? At the end of the day, why are we here? We should be making these better decisions. And so with that context, Equifax began to embark on, well, what can we do better? How can we do this better? Prasanna, when he came into Equifax, really challenged us as data scientists to take the best algorithms that are out there and leverage them. So before I dive into kind of what we're going to talk about, we have found this very helpful to provide an understanding of the landscape. And you've heard a little bit about this today. But we were talking to some of our investors. They were actually doing a series of articles about financial services companies and kind of their adoption of AI. And so we broke AI into three categories. The first one is learning from experts, expert rule systems. For those of you who've ever worked in the fraud area, right? You see an IP address coming over from the far east, Romania, Nigeria, and you go, wait, that's not where that person lives. Let me block that IP address, right? That's an expert identify that IP address, and we code it in the rules. The IBM Watson, for those of you familiar with that, that is an example of learning from experts. If any question that Watson did not get right on Jeopardy, they would program that answer in for the next time. Equifax plays in the learning from data space, right? You've heard a lot about neural networks, so I'm going to dive into that some more. That's where we're at, right? How do we understand the patterns in the behavior in the data? How do we mine the data so that we can better understand the customer? And then the third leg of artificial intelligence is learning from simulations. And that, we don't really play. I'd say about 90%, 95% of where we are at Equifax is in the learning from data piece, right? So what we've been able to do in terms of AI is we have been able to harness the power of it to identify new patterns. And one of the things that's been tremendous, and a lot of you are testing new data sources. You're out here trying to understand your customers better. We have found that artificial intelligence, neural networks are superior at doing that, right? They're able to comb through much more data, many more observations, and bring forth what is highly predictive, right? So it's a huge benefit. We are able to analyze full populations. When we first started with our neural nets in 2015, when we were first building them, it would take us a couple of days to run the algorithm, literally. Like, it took a long time. Now we can do that in 20 minutes, right? The ability for the data scientist to have a fully robust answer and the ability to iterate, test, and learn on it is very powerful so that we can optimize the models. We can capture interactions. We can look at multi-data assets like we never could before and combine those multi-data assets to drive new insights, which at the end of the day makes for better business decisions. So why are we discussing explainable AI? Some of these topics have been hit upon already, and let me just kind of build on them, is that it is definitely in the public consciousness, right? The reason I know this is for the first time in my life, my parents actually understand what I do, right? For those of you who are in this field, they're like, what do you do? You work with data? So they actually they see driverless cars, right? They see the explosion of data around them. They're more cognizant of it, right? This is something that people are being faced with, right? And so for us within our industry, it is critical that we approach AI not as a black box, but as something that is explainable. In fact, the term black box, I just shiver at, right? So let me tell you how this happened at Equifax in terms of how we discovered Neurodecision Technology and Explainable AI. We had built a new bankruptcy model, and it was predicting the bankruptcy of US consumers. And typically in a model building scenario, you get the data, and we would build an unconstrained neural net to see what the maximum amount of value in the data is. It's a very standard practice that you would do. I'm looking at a former colleague of mine at Capital One, and that's what we did there. And we'd look at the lift in the KS of that model, and then we compared it to logistic regression, the standard way that we did it, and we found that, oh my gosh, that neural net is now 10% higher KS. And we started to look at that and go, wait a minute, it's not a 2 or 3% delta. The algorithms are getting better, and we should really think about this. And so it boiled down to, well, what's the reason why we don't use those methodologies? And because of the regulation in the US, and I'll cover that. Like, we had to have something that was explainable. And so we basically were dumbing down the algorithms, right? We're using logistic regression when there are things that are much more powerful. And that sparked our work to get to explainable AI. From there, the team of data scientists in our data science innovation lab started doing research about, well, what are the methods of reject inference? What are the methods around explainability? What are the methods around reason code generation that we should look at? And that's how we started. So for us, it's never really been about the black box. The data scientist who co-patented it, he said at the time, it's only math. And he was right, it was only math. And so what we've done is we've actually broken that math down so that we can have a fully explainable algorithm. So I'll explain that as we go deeper. So economists is getting some good press today. But this is really interesting, right? We're in this data economy. And again, and any time you get into these sort of headlines, this always shows up, the Terminator, right? Like, it always is there. The robots are going to take over the world, we're in trouble sort of thing. But I think for us in this profession, we really need to make sure that we have that transparency. Again, a lot of the themes that we've heard already, and we strongly believe in that at Equifax. In fact, this week, I've been rotating around the various agencies in the UK, explaining to them what we're doing and providing them insight in terms of how we're doing this at Equifax. All right, so let me lay some context about, well, why did we go after explainable AI in the United States? So in the United States, there's this thing called the Fair Credit Reporting Act and also the Equal Credit Opportunity Act. And they require what's called a reason code generation. For every consumer who gets a loan, you have to provide 4 reasons regarding why they did not get the loan. Could be attributes such as not enough trades on file, could be things like too many delinquencies, too high utilization, standard credit attributes are there. And so it's required that we present those and provide those to the consumer for every lending decision. If you get a mortgage, if you get an auto loan, get a credit card, those reasons are provided. And therefore, we needed to have that full explainability. And it's in the credit scoring system. It actually says this in the rules, that the credit scoring system algorithm must provide the reason code generation. Okay, so that algorithm that's used to make the decision must be the reason why. So I couldn't say, well, trust me, consumer, it's a black box. It's good enough for me, must be good enough for you. I had to provide those reasons, right? And so the other thing to this is at Equifax we do a really good job of blending these two things, business performance, consumer fairness. On the business performance side, you want to know what your model's doing, right? You want to understand why it works and why it doesn't work. So there's a huge business rationale. As you go higher up in more strategic decisions, some of these models are actually deciding a country's bookings, right? So when I worked at Capital One, we had I was a scoring officer for the Canada model, right? That model basically was deciding the originations for the entire bank in Canada. You want to make sure that model's sound. You want to make sure you understand that model. You test it and you validate it. And one of the things I will say and leave with you, those of you who work in the kind of the regulatory space or in the model governance space at your institutions, or work with those people, the frameworks of model governance that we've had are great launching points for AI. AI is just an extension of really the practices that you have. You should continue to monitor your models. You should consider to have really good data sets. AI is not biased, right? An algorithm is not biased. The data that's feeding the algorithm can be biased, and those practices are well established about how do you measure those things. So how does this neural net work, right? So what we did at Equifax is, if you take a look at the left-hand side, these are the attributes or the features of the variables, right? And the right-hand side is what you're trying to predict. In this case, probability of default, right? If you ignore the gray circles for a second, just have the green to the green, that's logistic regression. Easily mapped. I can see the weight of x1 into the variable I'm trying to predict, default, right? And x2 and x3. Well, what happens when you have a neural net is that you then have these hidden layers. And then with these hidden layers, you have a different weight. So an x1 weight for the first node, the second node, the third node, and then another weight, and then another weight. You can understand where the complexity comes from. And that's when people would say, oh, wait, I don't understand that, right? Well, what we've done at Equifax is we've created a monotonic constraint in the algorithm. And this is what our patent's about, a monotonic constraint that allows you to have that interpretability. So what we've done is we've said, look, for that x1, that variable, let's say it's utilization, right? Or let's say delinquency, it's an easier one. The greater the delinquency that you have, the lower the credit score will be, okay? So if you have a high delinquency, that should be true for all people who are scored, right? The more delinquencies you have, the more problems that you have, right? The lower the scores you're going to get. And so that's what we've done, is we've imposed that monotonicity. So let's take a look at that, all right? The bottom graph right here, this is a surface space. And if you look at it, it's going up and down. There's peaks and valleys. This is a consumer, right? Consumers are not linear. If I look at my credit report, and I've looked at my credit report, there's a couple delinquencies in there, all right? And why? I don't remember why. This missed a payment one month. Did that make me a 550 credit score when I was previously a 750? No, not necessarily, right? But what you want to do is you want to make sure you can interpret the data correctly and accurately. And so what we do is the algorithm actually, it smooths out those surfaces, okay? Instead of having the peaks and valleys, you have increasing, but at changing rates, right? Increase at an increasing rate or increasing at a decreasing rate. And therefore, you're able to provide accurate predictions, and then therefore you're able to improve model performance while also using a neural net. We've also applied this to gradient boosting. We've done this with regression trees, random forests. So this methodology is very sound, and we've been doing it for a couple of years. We started testing it in 2016. We have models in the United States. We have a model in Canada. It's being tested in Argentina, in Europe as well. And so one of the things that's important in that we had to make sure we did is that we had an algorithm that was directly tied to the decision that's being made. I can't use a proxy algorithm for my reason codes, okay? I have to use the algorithm. That's by the law, right, in the US. And so things like explaining by average, by proxy, rules extracted, those sort of explanations of a model, I'm not allowed to do, okay? So what are the benefits of neurodecision, right? What are the ways that we've been able to extract value for our clients? So here I just showed a simple data set, credit data set, and we added our trended credit information, and we got an increase in KS. So the KS went from 31.8 to 32.8. And then we added our NC2Es, our National Communication and Telephone Utility Exchange data. Think of utility payments and mobile payments and cable payments. We added that data, and we got even more lift, right? More explainability in terms of credit risk. And then we added our neurodecision technology on top of it, okay? And what we were able to do, therefore, is increase approval rates by having that technology. So what's important is that it enables better decision-making, and it enables more lending. I can now use this information to actually provide more products to consumers. We've done a regulatory roadshow starting in 2016. We went to the OCC in the US, Control of the Currency, Federal Reserve, FDIC, CFPB. We just went to the NCUA. I can throw out as many three-letter acronyms as you want. But we went to those groups, and what was really interesting is the CFPB, the Consumer Financial Protection Board, actually invited us twice. They want us there again, because the first time we presented to their data scientists, and they thought it was pretty cool. But then they said, hey, we want you to talk to our lawyers. And we did this in front of the lawyers, right? We rolled this out. We kind of said, this is what we're up to. And Corey Stone, who was the lead policy analyst at the time, said to us, we cannot give you a good housekeeping seal of approval because we're regulators. We're not allowed to do that. But if we could, we would, because you've done two things. You've increased the ability, the safety and soundness of the algorithm by better predictive fit. But more importantly, the use case that we showed is that we were enabling 1 million more handsets without a deposit in the United States. That's huge in terms of the consumer, right? Do you have to pay $500 or $300 down to get access to your mobile network and your phone, or not, right? And that's what the power of these methodologies are. This is an example. This is an example of Neurodecision on a specific client. This is a retail credit card company. For those of you who are data scientists or statisticians, this is a horrible slide. My marketing team got a hold of this, and you notice you notice the axes are not at 0. I should be kicked out of being a statistician because of this, but it shows 86 to 98 and then 27 to 35, so it's a 7%, 16% lift. Makes it look really big. But anyways, this is actually really big, right? If you have a 16% increase in performance, that is game changing, right? That allows you to do things that you weren't able to do before. And that's, this client loved this. And what's really important is this custom model, it was made by another company, that was only a year old, right? They ditched a model only a year old for this one because of this performance. They were so impressed with it. So again, it allows us to improve accuracy, new products. We just built a new personal loan model in the US. And this was because of the kind of the retail, the digital economy, where you have a lot of fintechs with personal loans out there, really strong demand. And so this is compared against the Vantage score. It's a US score that's out there that's a generic score, and again, a 17% lift. Combination of the data, right, trended data, as well as our Neurodecision. And what we're finding is that trended data coupled with Neurodecision are an amazing combination. Why is that? Why is that? The reason is, when I built scorecards, what was interesting is like they were the 3rd or 4th generation scorecard on bureau data and that sort of thing. And you'll get some lift from a neural net, but when you add a completely new data source, this is kind of the things that you're able to identify patterns much quicker, much faster. Instead of a 3rd generation model finding an insight, kind of manually by the person thinking about it and coding it up, the neural net's able to do that. And that's what we're finding here. So we have thousands of trended data attributes, and we're able to sift and sort through those very effectively and find the ones that are most predictive, which leads to these sort of models. Let me tell you what's going on here. One of the things that, and I mentioned earlier that you cannot, around explainability and explainable AI, please do not drop the practices that you've learned that have got you here. They're good practices. Understanding your sample. Right? Really, do you have enough rejects or people that you did not approve in that sample? Those things still matter, right? So you don't have a biased population. Doing characteristic analysis, understanding the distributions of your data, looking at those things are still really important. Swap sets are still really important. So what we did here is we built a mortgage model with NDT. This is in the mortgage industry to understand how an incumbent logistic regression model would compare about a mortgage origination model. And I apologize because you can't tell the red from the red, but let me explain it to you. On the bottom are the swap outs. Okay, that's where the new model, the new neurodecision model says, gosh, these are really bad customers. You really don't want to, these are high-risk customers. I don't like these customers. That's what the neural net model is saying. And on the top, you have the model that says swap ins. Okay, this is bank card balance. This is amazing. The neural net model with trended data is saying, I want consumers who have very high bank card balance. A typical, like, really, you want a high indebtedness? What's going on? What we're doing is we're understanding the consumer better with the behavior. If you look at what's going on here, the bank card balances are going up. They get the mortgage at statement 0. This is when the mortgage origination happens right here. That's 12 months after mortgage, 24 months after mortgage, 36, and this is the prior behavior, right? Our trended data attributes are picking up that these people are paying down or would pay down that mortgage. They deleverage and they stay low. That's phenomenal. What you have here is you have the old model, oh, wow, they were low utilization, low indebtedness. That's not too bad. But if you can see what happens below 4,000 to above 6,000 right there, 50% increase in indebtedness after the originations, right? And then what happens from a 90+ rate? This is interesting as well. Again, we're able to identify that the consumer was working hard, right? Trying to swap ins, were working hard, and they were decreasing the delinquency rate. They get the mortgage and they go back up. This is a temporary phenomenon, right? So again, neural decision allows you, like, what's the whole forsake of what in this stuff? Allows you to understand your customer better, allows you to make better decisions, right? That combination of transparency, good sound analytics, good sound business practices enables better products. One of the things that we've done since these models have been around, we have model governance where we measure the impact of our models over time. What we've been able to see is that the unconstrained neural net may win, may be better in the short term. A year later, the constrained neural net, our neurodecision technology algorithm, is better. So what it's saying, this is the classic overfit story, right? So even with our neural nets being applied and validating on a holdout sample, all the good things that you do, right? You know, this is really, for us, this is key, right? What this is saying to us is that, you know, the non-monotonic shapes, the dips and valleys, those are temporal phenomena, right? Over time, you may say, oh, I have identified this group of consumers where the percent utilization, high percent utilization, is actually low risk. All right, that may be true for 6 months, may be true for 12 months, but if you have a consumer who has a percent utilization that is sustained high, it's going to catch up to him or her over time, right? And that's what we're seeing, is that the monotonic transformation is actually a really efficient way of smoothing out the data and generating a better model. We've applied this to gradient boosting machines, the methodologies. The first thing when we showed this to some folks, and they're like, can you do this with other algorithms? And we're like, yeah, we'll figure it out, right? Because some companies just say, hey, we use GBMs, others use, you know, neural nets, that sort of thing. But we've applied it to others as well. And then, as I mentioned, we've done the regulatory roadshow in the US. And this week, I did the regulatory roadshow in the UK. So with the help of Rona and Stuart Holland from Rona's team, we went to the FCA yesterday, talked to them about this. We went to the ICO yesterday and talked to them about this. And then we went to the Center for Data Ethics and Innovation on Tuesday and shared this with them. Because, you know, what's impressive about what's going on in the UK government is they're forming opinions around machine learning, artificial intelligence, and how to both embrace it and then, you know, put the appropriate guardrails on it. And so we strongly believe in the relationship with partners and regulators in terms of helping guiding them on here are the things that we're thinking about, here are the things that you should be thinking about. And so we started that practice, and that will continue throughout the year. And then obviously we had the patent that was generated in 2018. This is not a US phenomenon, right? What's fascinating about this is that in the US, the regulatory piece was the reason why we did it. What's fascinating is that, you know, FCRA is not a UK regulation. It's not an Argentinian regulation. The reason why people are embracing it, even though they don't have to provide the 4 reason codes, is the explainability. We've had really strong interest overseas. We built models in Australia. New Canadian model, it uses Neurodecision Technology. We just built a model for a branch of a bank in terms of its its assets in Poland, predicting what risk is going on there. And so we're very excited about this. We have a whole team of data scientists dedicated to artificial intelligence and machine learning. We're not just doing credit scoring, but we're also doing natural language processing, synthetic fraud prediction, using these new algorithms. And it's truly, I'm an optimist as well, it is truly an exciting time, right? You were able to solve problems that we were not able to solve previously. And in fact, in the fraud space, one of the algorithms that we now use is literally the needle in the haystack finder. We're able to identify, and we just did this, we just tested this with a client. We were able to identify synthetic fraud prediction. So for every 3 consumers flagged, 2 were fraud. For those of you who work in fraud, that is game-changing from an operations perspective. I call 3 people, and I identify 2 of them as fraud, right? As opposed to I call 5 people, and I only get 1, I capture 1 fraudster, right? So this is really big for us, and we're pretty excited about these capabilities. And then we've been on this journey. One of the things that Prasanna, when he came in to Equifax, he said, look, we need to invest in data science. We need to be shaping the destiny of our company using these advanced analytics, right? And so we started a data science team. NDT was the first patent, and now we're just going down the line here. We've just, one of the other patents that's not on here is around adaptive AI, right? So if you think about the feedback loop, the consumer makes, you issue a product to a consumer, the consumer's behavior, seeing what the consumer does on the back end, and then adapting the model for that. And more than happy to talk to you some more, any of you afterwards, about what we've been up to, but I want to thank you for your time.